Now that you are familiar with the use of the teletype, we can go on to use this for some other examples. Observe, I have just made some edits to what I would consider to be a template. So now I'm going to go ahead and save this. But generally I like to keep my templates sacred once they're created. So what I'm going to do here is set this to read only, and now it won't let me make any edits. I can copy it back over to my test or whatever, but now it will stay the way it is. I'm going to open test, up one, test. Now I can close my template. And of course, there, we want to be specific, which we do, really. We're going to next, I'm just going to set this character back to 3, I think, and color 4. In this next example, let me see here, let me just quickly save test, and I'm going to, no, I didn't want to open a new command prompt. Oh, apparently I do. I must have inadvertently closed it before. Let me copy my path. Current directory path, go to CD, paste, there, back where I belong, I guess. Alright, so that means, if I want to just NASM minus F binary file, T-tab minus O B-tab. There, we have compiled this, so I can look at B-tab, assembled it, compiled it, it's all the same. Okay, kind of a bit of a jumble of numbers. What I would like to do, as you know, we can go here and call interrupt numerous times, and it will do this same thing over and over, right? It'll print the character and then print it again and print it again. Yes, we know that. We could also, from here, jump back to this point and then repeat the same command. That's what I'd like to do. And here, it's not exactly obvious where that jump point is, so what I'm going to do is right here, create a little roadblock, I guess. Data word FF, oops, FF, but it's going to be in hex 0x, like that. Hexadecimal value. So now if I save that and then go to my command prompt, and I just want to NASM it and then look at it. We're not going to run it in QEMU. There's my little bookmark. Yeah. So normally the CD10 would begin here. CD10, of course, hopefully you recognize by now that is int16. In hexadecimal is CD10. You come to recognize the various commands just by looking at them in your hex editor after a while, which is convenient if you're doing your lower level assembly and working in binary and hex. Okay. Here's where we want to be. So if I click here, well, it tells us here, but it also, if the code were somewhere way down here, it tells us the offset down here, which can be convenient. So I want to jump to 0C. Now here everything is in hex. There's a way to also set it, so like under options, view, I think, offset based decimal. Oh, yeah, see, look, now everything's in decimal here. Look, there's the real numbers, and so if I wanted to jump to 12, see, that's where we're going in real value, right? But either way, let me just for the moment set that back. Hexadecimal, yeah, but it's in there. You know, you can look at it either way. Okay, so it doesn't say 12 here though. Why is that? Because these lines are not spaced accordingly to the amount of bytes that they use up. As we can see here, move AX word. Let me click here and then here. It takes up 3 bytes, right? But on the screen, it only takes up 1 line. So what if I, whoops, added a little extra space there. So now this begins, we're not counting the 0. It's actually, I mean, if this was 3 spaces, it would be like that, but we're going to pretend that there's a 0 line in this editor, okay? So we want the next command here to begin at 3. Okay, there, now it does. And the next command after that, this takes up 2 bytes. Okay, so we're good down to here to 5. Okay, there's the next command. How many bytes does that take up? That takes up 2 bytes. So 1, 2, let me add a enter there. So then the next command begins at 7. Click here. That takes up another 2 bytes, you see. So the 9, move BX is this one, I guess. If I click here, that takes up 3 bytes, you see. So after move BX, then boom, like that, until our FF. Okay, so now this comes in. Let me remove our little note to self here. Okay, so now, what do I say? This is 3 bytes. No, there. So now this comes in at line 12, right? Which is C, right? So I can now, from here, jump back to here using a jump command. And let's just go ahead and write it in hex, OXC, okay? I'm going to save that. And then we will go over here. We will NASM it, and then QEMU RB tab. There. So now there, it's expressing its endless love to you. And we are, we're in an endless loop. Yeah, it's printing the heart over and over and over and over. It's not like it's gonna fritz out your computer. That's what your computer does. It's printing the screen on your computer over and over and over and over and over continuously, you know, and that's what allows your mouse to move and create animation and such, you know. So there you go. That is an explicit jump. You know, we're jumping to a specific point in memory. Let me just again set this back to decimal. Okay, yeah. We are jumping to, again, CD10 is the command that we know as int16, call and interrupt. And here I've set it to decimal so we can see it begins at line 12. So instead of using hex, I could just as easily say in decimal, jump back to line 12, like that. Save that. Not like that's a huge difference, but why don't we just look at it anyways. There you go. And I might as well Control-Alt-F for full screen. There. So there you go. You can show this to your significant other and go, here, look, this is all that's running on my computer. My endless love for you. Okay, folks. Okay, so that is explicit jump.